Okay, lesson 22, we are going over analyzing continuous and discontinuous and discrete functions. Basically, you're just going to be identifying these functions, answering some questions about them. We will also be talking about domain and range in more of an advanced way. So, starting out, you guys have a bell ringer there. I want you guys to work that out on your own. I don't really have the time to do that right now. I want to get to our lesson here pretty quick. So, check with me. I will have the answer for you guys. Now, three types of functions. The first one is continuous. What you need to know about a continuous function is that it goes on forever. Okay, there's not going to be any jumps. There's not going to be any gaps. There's not going to be any asymptotes. If we look at this first one right here, this is a line that goes on forever. There's nothing that stops it. If we look at this function here, this is a line. Yes, it's curved, but it goes on forever. There's nothing that stops it. Okay, if it is a continuous, smooth curve, that makes it a continuous function. Next one is discontinuous. Hey, this one looks like that same one that we just went over. What's the difference? That open circle right there. We call that open circle a point of discontinuity. All right? Just means that there's a gap there of some sort. So that specific gap, that one thing, makes it discontinuous. This function over on this side, there's a gap right here in the middle, right? It looks like two different continuous functions. Since there's this gap, that makes that function discontinuous. We call that gap an asymptote. Okay? It's represented by a dashed line. This is discontinuous at x equals 0. X equals 0 is the vertical line there. Okay? I know we've talked about asymptotes a little bit, but that is what an asymptote is. It's essentially a gap. There's a jump. That makes it discontinuous. The last one that we have is discrete functions. I can't remember who said it, but one of my students, my first year that I taught this, said a discrete function is just a bunch of dots. Okay? And that's exactly what it is. There's no lines connecting them. There's just random dots all over the place. That makes it a discrete function. So if you see a bunch of points, it is called a discrete function. So we're going to look. We got some different examples up here. What type of function is this one over here on the left? Well, I see a hole there. And if there's a hole, that means that it has to be a discontinuous function. Okay? It also asks us to name the point of discontinuity if one's there. The point of discontinuity would just be the point 6, 5. Notice the graph is moving up by 2. That's why it's 6, 5. Next function that we're looking at, we've got an upside down parabola there. Okay? Are there any breaks, gaps, or jumps? Nope. It is one continuous smooth curve, which makes that a continuous function. The next one that we have looks like a whole lot of dots to me, which is going to make that a discrete function. Okay? That's the first part of the lesson today, just describing these types of functions. So let's practice. They may have you graph one of these functions here. So this function has a point, a point, a point, and a point, which means when I graph that, that's just going to be 4 dots. There's no lines connecting them. So this is a discrete function that it's asking me to graph. All that I do to graph a discrete function is I graph the 4 points. Do not connect the dots. Do not connect the dots. Okay? A discrete function does not have a connection between the points. Now, it also asks us to find the domain and range. Domain is going to be your x values. Range is going to be your y values. So for a discrete function, you're just going to list your x values for the domain. It's -7, -4, -1, and 4. And then I'm going to list the y values for my range. They can ask you guys to graph other types of functions. This time they've asked us to graph the continuous function, which is f of x equals -2x plus 4. If you guys remember, f of x is the same thing as y. So what I have up here, I've got f of x equals -2x plus 4. That's really just a y equals -2x plus 4. This is what we worked on in lesson 13. Okay, that's just a line in slope-intercept form. So we can see I've got my y-intercept at 4. My slope is a negative 2 over 1. So I could go down 2 to the right 1, down 2 to the right 1, and I have my line. Now, it also asks us to state the domain and range. This is going to be new for us, domain and range. Okay, we know that's x values, we know that's y values, but up to this point, for our domain, we've just listed x values. And you guys can see that this does have points with x values. But my domain is not just going to be those points because there's a line between those points. So we're going to have to use an interval. And when I say that we're going to use an interval, I mean we're going to have something like x is greater than some number, or x is less than some number, or it could be y if we're talking about the range. Now, if I look at this line here specifically, this line is going to the left forever and ever and ever. There's nothing stopping it from going to the left. There's also nothing stopping this from moving to the right. It's going to the right forever and ever and ever. Basically, since there's no gaps or jumps in this, my domain is going to be all real numbers. So when I list my domain, that's my x values. Okay, I'm looking left and I look right. My domain for this function is simply all real numbers. It's not a list of the x values on the coordinate. It's just all real numbers. If I look at my range, which remember your range is going to be all the y values that are present, okay, that means I'm going to be looking up and down. Is there anything stopping this from going up? No, it's going on and on and on forever and ever. Is there anything stopping this going down? No, it's going on and on and on forever and ever. Therefore, this one's range is also all real numbers. So for this particular function, its range is all real numbers, and its domain is all real numbers. That will not always be the case. Let's practice a little bit more here with our domain and range. Okay, I've got 3 functions again. It asks to determine if it's continuous, discontinuous, or discrete. Then it asks to determine if it's a function or a relation. Okay, function or relation, all that is using our vertical line test. Okay. The last part says determine the domain and the range of each. So if I look over here on the left, continuous smooth curve, it's continuous. Okay, is that a function? Yes, I'm running vertical lines up and down. I don't have any spots where it hits twice. So I could say that this is a continuous function. Next, I've got to determine the domain and range. Domain is my x values here. Is there anything stopping this function going to the right? No. Is there anything stopping this function moving to the left? No. Now, it's not necessarily moving very much to the right, but there's nothing stopping it from moving to the right. So since there's nothing stopping it to the right or stopping it to the left, its domain is going to be all real numbers. Now for my range. Range is up and down. That's my y values here. Is there anything stopping this function from going up? No. It's going to go on forever and ever and ever. Is there anything stopping this function from going down? Yes. The bottom of the u. Okay? This has the lowest point possible, and its lowest point is right here. So the lowest y value that I could possibly have would be that y value there. Notice it's moving up by 2. So my range is going to be y has to be greater than or equal to 2. Down below 2 here, there is no function, and there never will be a function down there in this case. So my range is going to be y is greater than or equal to 2. If I look at my next function here, 3 little holes. That's not a continuous function. That's a discrete. Not discrete. That's a discontinuous function. Okay? Now, I kind of jumped the gun a little bit there about the function. Does it pass the vertical line test? Yes, it does pass the vertical line test. So that's a discontinuous function. And then my domain for this one. Is there anything stopping it going to the right? No. Is there anything stopping it from going to the left? No. Is it all real numbers? No. Because there are 3 values right here that are not included. So this is all real numbers except these three values. So my domain for this one is x, because domain is talking about x values, and it's x cannot equal the three values where the gaps are. Okay, so this value right here, its x value is -3. This value here has an x value of 1. This value here has an x value of 5. Okay, so it's excluding. It's all real numbers except these three. Your range for this one is y is greater than or equal to -3. Sorry, I'm kind of going too quick here. Nothing stopping it going up. Nothing stopping it going up. There definitely is something stopping it going down. This right here has the lowest values. Okay? And if I look where its lowest values are, they're on the graph at -3. So it's everything that is above -3. Last one here, looks like a whole lot of dots to me, which makes that discrete, and it is a function. There's no dots that are overlapping on the vertical line. Remember, for discrete functions, we are just listing because there's no line in between them. So my discrete function is going to be, my domain for my discrete function is going to be -2, 1, 5, and 9. All of the x values of these points. Your range value is going to be y equals 8, 6, 4, and 3. All of the y values of these 4 points here. Next, you guys have your lesson practices. I'd like you guys to do those on your own. When you come back in, I can have something so that you guys can check them, make sure you understand what you're doing. I am going to give you guys a heads up here. H of x equals 5. Remember, that's y equals 5. That's a special kind of line. You may need to look it up. It's either horizontal or vertical. I want you guys to try to figure that out on your own. Okay? Good luck. If you have any questions, come see me. Your homework is listed on the back page right here.